It's working. Okay, thank you. Okay, good afternoon, everyone. And I'm super excited, to be here today. And I want to welcome every one of you to this new semester and to my course. Okay, so today I'm actually going to give you a little bit introduction about myself. And I'm also going to talk about the class expectation. Okay. Okay. So of course, my name is Kazim. Okay. I'm originally from Nigeria. Has anybody heard about a country called Nigeria? Okay. Thank you so much for that. Um, actually, I started my teaching career unofficially in 2005, but in 2010, I started officially. So I started from Nigeria, spent, teaching at college level for years before relocating to United States. And of course, this is going to be my fifth year at the School of Statistics University, this university. I'm also an assistant director of undergraduate studies. Of course, I'm going to tell you I have a PhD in mathematical statistics. I specialize in the area of robust statistical modeling. So there's no area of statistics that I cannot, explain. But let me tell you, this is the way I teach. My experience in teaching in Africa, Europe and United States, I basically, particularly teaching mathematical related subjects, I realized, some students have phobia for anything mathematical related. And you know why they have that is because they don't relate whatever symbol notation to real life. Okay, so, um, when you are learning this course, because it's actually going to be mathematical oriented, I needed to pay attention to notations, equations, what is the essence of sigma, the essence of whatever notation in real life. I want to believe the moment you understand the application in real life, you're basically going to be fine. I actually acknowledge the fact that the course may be challenging, but you're basically going to find this course more rewarding with me. I want this lecture to be a statistical party. Okay, I want a situation whereby, you always want to come to this class, and what I need from you is to ask question if you don't understand. Let me tell you, the greatest sin to me in the whole world is not murder, even though I don't encourage anyone to do that. But the greatest sin in the world is when one deceives oneself. I can deceive somebody else, and it's not good to deceive somebody. When I deceive somebody, they can report me to police or report me to somebody, But what if I deceive myself? Who am I going to report myself to? And that's why I shouldn't deceive myself. You pay for this service, you deserve to be served better. And that is the reason why, you understand better yourself better than any other. So the moment you realize a particular topic, a particular concept is not clear to you, please ask question because you pay for the service. I want to believe some may not want to ask question in class, but send me a message, okay? Or you meet with me during my office hour. Now I'm just going to conduct my office hour via Zoom, so which means you can be anywhere in the world, to attend my office hour. It's going to be on Tuesdays, and that is going to be between 10 and 12. And of course, you can also give me a call, and whatever you discuss with me will be treated with absolute degree of confidentiality. Okay? So feel free with me. Take me as your friend. Okay? Okay, so I'm actually advising that I believe you all have access to Canvas, a lot of information on the canvas about the number of assignment. Okay, there's the good news is there's not going to be assignment this week because we're only going to have 2 days of lecture. Assignment will be posted every Sunday night, and it's going to be due for submission the following Sunday night. Of course, I think I've already outlined, the due date for submission of assignment. I needed to check our Canvas. Okay, I also give extra credit in case you answer my question in class. When you answer my question in class correctly, you basically going to have 1 point. You can be accumulating, those points. And at the end of the day, I need you to send me a message on how you want to spend it. You could spend your extra credit on assignment. It could be on the midterm. It could be on the final. Okay? So you can be accumulating that, point. Okay? So I want a situation whereby everybody will participate, okay, when you are here. And lastly, follow whatever you're going to do with analytical mind. Okay? I remember when I'm teaching, I forgot to tell you that I have 5 girls. So 5 girls, one in college, studying nursing at Winona State University. The second one is in high school, 10th grade. So I have a third one, middle school, 7th grade. Then I have one in 4th grade and one in 3rd grade. We've been very, very busy. I remember the one in high school normally asked me a question, my dad, what is the meaning of X plus Y equal to that? It doesn't make sense. But, I'm going to say, okay, let's X be the price of cookies. And my daughter is going to say, okay, I know cookies. So what I'm going to be doing in this class, okay, I'm going to be relating whatever we do to real life. And I'm also going to tell you what is behind the scene. The moment you understand the question, the reason behind the question, the reason behind notations, you're basically going to appreciate what you are learning. So in case you get stuck, please let me know. Okay, any question? I used to ask this question, even though this is my 5th year in this university, and this is my 7th year in the United States. I normally ask, is there anybody in this class who is struggling with the way I talk? Oh, okay. That's what I used to ask. Communication is I'll keep on improving. Okay, that is that. That's my email. Let's get started. Probability versus statistics. Okay, this is what I'm going to do. Why do we find ourselves in the world where we need to study probability and statistics? Why? I want to believe, there's a reason why we are studying this. And I'm going to give you the account of that right now. And I need you to pay attention. The existence of reality, okay, is independent of human knowledge. I'm going to say that again. Existence of reality is independent of human knowledge, and which means initially we don't know anything. Initially, okay, we don't know anything initially. But you know what? We want to be secured. We want to understand our environment. When I talk about environment, I mean I want to understand my medical environment. I want to understand my economic environment. I want to understand my political environment. I want to understand my psychological environment. I want to understand, everything about my environment. And why do you want to understand your environment? Okay? Because of the fact that there's a variation. Different things happen in different days. We worry. You know why? Because of variations. Because of the fact that different things happen in different days. At times, we're going to be happy. At times, we're going to cry. I don't know why. Okay? At times, when I come back from work, I'm going to see my wife. She's going to be happy. And at times, when I come back from work, he's going to like, what's going on here? That's a variation. Okay? But do you know that if maybe every day, if she actually exhibits the same character every day, I don't need to be worried. Okay? We get worried because of variations. Okay? And because of that, it makes our environment to be complicated. Okay? And when our environment is complicated, we basically want to secure this environment. We basically want to understand this environment. And for us to be able to understand the environment, then we need probability and statistics. Because why? Without variations, there can never be probability and statistics. Okay, now the environment that we're talking about, the happenings in the world is stochastic in nature. Okay, it's stochastic. Stochastic, and anything that is stochastic is probabilistic. Probabilistic. Okay, so the environment, the reality is complicated and probabilistic. Now, when something is complicated and is probabilistic, then you need a probability knowledge to figure it out. Does that make sense? Because there must be an agreement between, a state of nature and whatever technique you want to apply. They must agree. And that is why. So what I'm trying to say, probability and statistics actually thrives in variation. If there's no variation, there's nothing to manipulate. There's nothing to worry about. That is the reason why we find ourselves studying probability and statistics. Now, another question is there any difference between the two? Or can the two be used interchangeably? Then I'm going to tell you now. Oh, go ahead.
So you wrote that word stochastic.
Yep.
What does that mean?
Yeah, stochastic is like something that is changing randomly, like that is probabilistic in nature. That's what I mean. That's a good question.
Thanks.
You're welcome. Okay, before I move into the difference between the two, we got two states of nature. Okay, number one, we have one environment and multi-environment. When I say one state of nature means the same thing happen different days. That environment does not exist under the sun. But the realistic environment is having a multi-state of nature. And what leads to multi-state of nature is because of variation. I don't know why there's variation, but the only thing I can talk about, there's beauty, there's a beauty in diversity. That's what I'm saying, you're wearing different colors or different styles. Oh my God, that make this place so beautiful. That is what I can see. I don't know why that happened. Okay. Now, we have a probability and statistics. Let's take a look at this. What is statistics? What is probability? Let's start with statistics. Okay. By statistics, we're talking about analyzing the frequency of past events. Okay. I'm talking about statistics right now. Statistics. Okay. Statistics. Okay. Analysis of the frequency, okay, of past events. Because when you take a look at basic science, in basic science, we basically want to understand our environment. If we want to understand our environment, we need to go retrospective. Okay, we need to go historical. Okay, analyzing the data, the data that you have, okay, is something that happened in the past. So you are analyzing the frequency, okay, of past events with statistics, okay? But you know what? When I'm talking about probability, okay, so that actually deals with predicting, okay, likelihood of future occurrences. Let me tell you this. If you take a look at it too, okay, this is talking about the analysis of frequency of past event. Okay, if I want to analyze the frequency of past events, what do I mean by frequency? It's more or less like we're talking about the numbers of time a particular event occur okay, that's frequency. Okay, when you're talking about frequency, then you can't rule out probability. Because the probability is also called, it's about frequency. It's talking about, the certain characteristics of interest, okay, divided by totality. Okay, which I'm still coming into that. Okay, so which means in statistics, we use element of probability theory. And I'm going to give you an example right now. But with the idea of probability, we basically want to predict the future. Now, if you take a look at what I'm seeing here, I'm seeing basic science and applied science. In basic science, we try to understand the world so that we can explain the world. But in applied science, can we move, a little bit forward, predicting what is going to happen next? There's a difference between explaining the world, understanding the world, and predicting the world. The two are not the same. I'm going to give you an example. I manufacture this car. This is a car. I manufacture this car. I know everything about this car, but you know what? I cannot predict where this car is going to go. Do you know who can predict where this car is going to go? It's the driver. The driver that is driving the car. I may be thinking it's going to be in Chicago, and this car is already in New York. So explanation is different from prediction. Okay? Now, I'm going to give you an example now between statistics and probability. And you're basically going to see. Okay? Now, if I have this, okay, and basically in a box, okay, I got 60% of black and 40% red. Okay, this is looking like in statistics, we actually have a population of interest. Like if I want to carry out research, okay, I need a target population. Okay, let me just say I'm interested in balls, okay, and I got two different kind of balls, distinguished by color. 60% of that is black, 40% of that is this. Now take a look at this. Okay, maybe I choose a sample. Okay, here, this is like my data sample that I choose. I choose 5 balls randomly from a population, okay? And I realize that 2 are red and 3 are black. Now, I want to explain the difference between probability and statistics now. If you don't understand, I need you to ask questions. This is it. What probability is, or let me just start with it. What statistics is talking about is this. Okay, I know what I have in my hand. Okay, I know what I have in my hand, but I want to predict what is going to be in the box. When I say box, I mean population. Okay, now take a look at this. Okay, I've randomly select 5 balls, and it is observed that 2 are red and 3 are black. Okay, now after doing this, now the question I'm going to ask, is it likely that 60% of balls will be black? That is statistics. I'm going to say that again. Okay? A statistician collected, draw a sample of 5 balls randomly from a population of balls, and he observed 2 to be red and 3 to be black. This is from the sample. Okay? In statistics, we don't study entire population. We take a sample, okay? Okay, we're going to make sure we choose the sample randomly, okay, so that we're going to give equal chance to every ball in the population. But I'm behaving like a statistician now, okay? Performing the role of a statistician now, okay? I select 5 balls randomly, and I observed 2 are red, 3 are black. This is what I have in my hand right now. Okay, when I have this in my hand, then what do I want to do? I want to make an inference about the population, with the knowledge of the sample, Okay, with the knowledge of the sample, I basically want to make an inference, a judgment, a conclusion about what I'm going to have in a big bus, which I call the population. Okay, I'm now going to ask myself question, okay, is it likely I'm going to have 60% of the bus in the population? Okay, that is statistics. And if I want to do that, I will use probability theory to do that. Okay, now let me now come here now. Okay, now, if you take a look at probability on the other hand, okay, I'm going to probability now. You know, I just talked about statistics, right? With probability, I know everything that is in the box, in the population. Okay, I know everything. I know that in this population, we got 60% black, 40% red. Okay, now, what I'm going to do now, if I take a 5 balls at random from this box, what is the probability that 2 will be red? Then that is probability. Does that make sense now? I'm going to say that again. So which means, in probability, we already know what is in the box. Okay? Now, we now want to make, we want to talk about what is in the hand. I will know what is in the box. But for statistics, we know what we have in the hand. Can we have a way to predict what is in the box? The box is larger than what you have in the hand. Does that make sense to everyone? That is the difference. Is there anyone who's not clear about that? Is there anyone? Okay, go ahead.
So you're saying that if we know the population and we want to say we're going to pick 5 balls, how many of those will be black? That is probability.
Exactly.
We have the data sample and we know what we picked out, and we know what that, it's 30% or 60% black, then that would be statistics.
Yeah. So if it means from your sample, you have observed certain characteristics of interest, you now want to have the view of the general population. That is statistics, which means you already have it. It's just like I'm at home and my wife is cooking, and I can hear I smell something nice, and I say, okay, can I have a taste of that? Okay, of course, I'm not going to eat the whole pot. Okay, in statistics, we take a sample, right? Okay, I'm not going to eat everything. So, but my wife is now going to dish a part, which is going to be a sample, but I'm going to tell my wife, make sure you steal that homogeneous so that you can dish any parts, which means I want randomness, okay? By the time she gives that to me, and I say, oh, this tastes nice, what do you think is going to be my mind? I will generalize that, okay, the way that tastes, that small part tastes, that is the whole pot, the whole soup is going to taste. That is statistics. What are you doing? You are making an inference. You are generalizing, okay? You are taking a decision on a population based on your observation of a sample. That is statistics. Go ahead.
So, kind of adding on to that.
Yeah.
Does the statistician or statistics choose the sample size, or is it a given? Like, why would you stop at just 5 balls?
Oh, that's a good question. That's another topic in statistics. We call that sample size determination. Like, how do we determine our sample? Does that make sense? So that's another topic. Yeah. Okay, that's a good question. That's a good question. Now you know the difference between probability and statistics, but you know what? They can never be separated. The two of them. They always go together. But that doesn't mean they are the same. They are not. Okay. Now, I want to go more into probability now. You've heard about story like from Dr. Houston, the probability so many times. At times, when somebody is sick, they're going to say, oh, it's 50-50. The question now is, how did they arrive at that? They arrive at that because they compare that to, their experience. Like, patient, if 100% of the patient have that same illness, it's only 50 that survive. What are they doing? They're using the knowledge of the past, okay, for them to say it is 50-50, okay? And some basically going to say, somebody have 95% certain that a particular, disease is present. Okay, so that is more or less using the idea of probability, trying to relate the experience, about that same thing in the past. And the same thing happened to like this, okay, there is a 75% of rain tomorrow. How did they come? How did they come to 75%? So which means when they consider 100 days in the past that have the same similar weather condition, 75 out of the 100 days have ended up, raining. So which means we need to go to the past a little bit to understand what is going on. Okay? So that is the meaning. Okay. Now we want to go into divination. Okay? Now this is what happened. We have a formula for probability. Before we can talk about probability, we need to first understand what I call a sample space. Sample space actually means collection of possibility. Okay? And the sample space can be partitioned into several events. Okay? Now, if I'm interested in probability of a particular event occurring, of course, it's basically going to be the number of that characteristics of interest divided by the totality. If you take a look at what I have here, okay, if I perform experiments n number of times, okay, and this is the numbers of time favorable. What do I mean by favorable? It means before performing an experiment, we got something in mind. Our mind can never be empty. It's just like a businessman or woman. What do you think he has in mind? Making profit. Okay? The event of making profit is going to refer to that as success. But we live in a world where at times we make profit, we make loss. Okay? Out of the numbers of trial that I have, how many successes do I have? If I want to figure out what the probability is, it's just going to be the ratio of the numbers of time favorable divided by the totality. Okay? That is what that formula is actually talking about. Okay, the whole things we start with the experiments. It is not until you are in a physics lab or a chemistry lab or a biological lab that you perform experiment. Life itself is an experiment. Let me just give you the definition of experiment. Experiment is anything, any trial that generates an outcome. Any trial at all that generates an outcome. That's what we call experiment. And before you go into experiment, you got something in mind. As you are here now, study, you're going to write exam, right? You are experimenting. At the end of the day, you said that somebody passed or somebody failed. But I know a good number, in fact, everybody wants success. But that doesn't mean failure cannot occur. Okay? And that's why I used to tell my wife, at times when we are happy, I used to be very, very careful when something happened and we are happy because I know something that may not nice is still going to happen. When we are happy, we need to prepare for challenges ahead. At times, we used to get overwhelmed by success. And when the other one arrives, then we may not be able to figure it out. Because it's part of life. Don't forget, there's a variation, right? Okay, any planned process of data collection, and that consists of having numbers of trials under the same condition. I take a coin now, okay? And we got in a balanced coin, we got two sides, right? Head and tail, right? I don't just toss a coin. I got something in mind. Maybe before going into this research, I basically want to know how many numbers of heads I'm going to have. So when I go into the experiment now, and I actually flip number one, I'm gonna take note of what I observe. I continue going like that. It means I'm performing this under similar experimental condition. But you know what? At different trial, I'm getting different results. Take a look at that. And that is basically going to be called a random experiment. because you are getting different results at different trial. Okay? Now, okay, if you really want to understand probability, like I said, you need to understand the sample space. Of course, the sample space is a collection of possibility. Okay? Collection of possibility. Okay? And out of the possible outcome, the favorable outcome is actually inside that. Okay? I just wanted to take note of that. So if you want to understand probability very well, you need to first understand sample space. Okay? Which I call the totality of the possible outcome. And of course, then there's something that we call simple event. When I talk about simple event, I'm talking about a particular outcome within a sample space. I'm going to give an example. Now I give an example here talking about, I said, one outcome in the sample space, a possible outcome of a random experiment. For instance, I said a collection of one or more simple events, like if I have, this can be a sample space. Maybe I'm focusing on gender, okay? And I say, okay, that's a sample space, okay? Is that that or that, okay? Okay, now, that's a sample space, okay? Now, another thing I want to talk about is a complement, okay? Now I want to start using a notation, A. If I call A to be an event, okay, for those of you who like American football, okay, I know you like watching Vikings, right? Okay, now it's either Vikings win a match or not, right? Now, if we let A to represent the event of Vikings winning, then we also need to consider another possibility of life, okay, which is going to be losing, right? Now, statistically speaking, we're going to call that a complement. Okay, like success is a complement of failure. Okay, symbolically, we're actually going to use A bar or AC, okay, as the complement of A. So when we're talking about the same way we said the complement of female is actually male, or the complement of success is, failure, and so on like that. That's what I mean. Okay, now, because of that, we got implication. And I want you to take note of this right now. Let us assume in my sample space, if I have success and failure in my sample space, and actually denote, let A represent the event of success, okay? Oh, I'm going to use green light, go, okay? Green light, go, red light, stop. I'm going to call this success, okay? It's in my sample space, I'm calling that A, and this is failure, right? Also in my sample space. If I name this as A, then I'm going to name this as complement. If I only have two of them in my sample space, if I only have these two in my sample space, okay? Now, if I have these two in my sample space, then what it means is that they are mutually exclusive. What do I mean by mutually exclusive? Is that it's either I have this or this, okay? If I'm actually happy, okay, it means the event of happiness has already prevented the other event. Okay, so that is what we mean. They are mutually exclusive. And you know what? Because they are mutually exclusive, if I consider the probability of this guy happening and the probability of this guy happening, by the time I add them together, they become the probability of the sample space. And what is the probability of the sample space? Is 1. You know why probability of sample space is 1? Because one event will happen in the sample space. That is possible. And that is why we call that a sure event. We call the sample space, okay, the probability of a sample space, probability of a sample space, we call that to be a sure event. A sure event, we have a probability of 1, okay? Now, because of that, I can actually say probability of A plus the probability of that equal probability of the sample space equal to 1. Which is what I have there. Okay? the probability of success plus probability of failure equal to 1. Why do I have a plus? I have a plus. The plus actually means, or, there's a conjunction, this, or in mathematics, whenever I mention this, it's basically going to attract an additional rule in probability. It's that I have this guy or I have the other guy. Okay, so that's why you have what you're having now. Any question? Any question? Okay, I want it to be a party. Don't forget, I want it to be a party. So the moment you are not enjoying my statistical cookies, candies, please let me know. Oh, go ahead. Yeah. Oh, I mutually exclusive. You said what about inclusive, right? Oh, inclusive. We are still coming to that. We're talking about inclusive. It's more or less like there's possibility that you also have the joint. Okay, they can occur separately and they can occur together. I'm coming to that. We all normally call that non-mutually exclusive. Okay, we're still coming back to that when we come to two events. Okay, good job. Good job. Okay, now take a look at this. Different statisticians, they normally get different results. Why? Don't forget, statisticians use the knowledge of probability. And we got different school of thought in probability. And that's why different statisticians get different results, even when they are working on the same thing. I'm going to give you an example now. Some statistics, because we use probability theory, okay? Statisticians use probability theory. Even though we're working on the same situation, we are likely going to have different results. But having different results can actually be attributed to different school of thought in probability. Now, we want to talk about different school of thought in probability that I'm actually going to call views of probability, okay? I want to start with subjective. When you hear subjective, subjective is basically based on your experience, okay? Your state of mind, okay? Okay, let me give you an example. Let's say I say, okay, tomorrow I want to go and fight with, who is the current, I want to remember that American boxer, Mayweather. If I tell you in this class that tomorrow I want to go and fight Mayweather, what are you going to say? Oh, because I'm not a professional boxer, you're actually going to rule me out. Okay? That is what we call subjective. Okay? When you are using the principle of subjectivism, okay, that is why we said it's an estimate that reflects a person's opinion or a best guess about that. You are not going to give me, it's not going to be a 50-50 situation. Okay? And doctor actually use that most of the time. For instance, a doctor came in very sick, and I know before they're basically going to recommend any diagnostic testing, the doctor is going to touch the patient's hand. Okay, they check and using his experience in the job, is going to have something in mind. Okay? In fact, we need that for doctor to recommend a good test. Because if doctor is not using experience, okay, the patient is just going to be subjected to different kind of tests. And before you know, this patient is dying. You're going to spend a lot of money. But if doctor can use his experience, okay, by the time he has a physical examination with the patient, they can actually recommend. Now, take a look at this. I said, that form a basis of physician opinion based on information gained in the history of physical examination about whether a patient has a specific disease. But let me tell you, that could change, okay, after diagnostic procedure. Does that make sense? And that was why I said such an estimate can be changed with the results of diagnostic. So this view in probability is actually called subjective. Okay? Now we get another view. Okay? And that very view is what we call objective. Okay? Classical. So here, we don't want to use our past experience. We actually, we're not going to be biased here. we basically want to talk about, address this situation based on empirical analysis, based on what you observe, on empirical evidence. And that was why I said, everybody knows when you have a coin, I mean a balanced coin, because some coins are not balanced. Okay? Now, we have head, we have tail. Okay? In a fair coin, the probability should be 0.5, right? For a balanced coin. Okay? But let me tell you this. If a coin is flipped 10 times, and there's a guarantee of exactly 5 tails will be observed, okay? Well, let me tell you this. At times, that is not going to happen in an experimental probability. That's just theoretical. Theoretical, the classical is just going to tell us, okay, you know what? When I toss a coin 10 times, the numbers of time head is going to show up should be 5. And when it comes out to be 5, then I'm basically going to call that a balanced coin. But you can try it when you get home today. You can flip a coin 10 times. You are not likely going to get 5 out of 10. Okay? But let me tell you this. We acknowledge that fact. But on the long run, like when you have, and that was why I said, if the coin is flipped 100 times or 1,000 flips, okay, as the number of flips becomes larger, the proportion of coin will actually going to be 0.5. It may not be 0.5 when you have a small trial, but what we're trying to say on the long run, okay, is basically going to be 0.5. Okay, that's what we mean. Okay. Oh, I got 5 more minutes. Okay, so I'm going to give an example now. Probability of male versus female bats. Okay, and we basically want to use an example from KSA. Okay, the long run relative frequency of male born in KSA is about 0.512, which is of 512 boys, born per 1,000. And we now want to conduct a simulation. Okay, in week 1. You look at what happened in week 1 out of the total bats. This is more or less like small, right? Okay. How many boys? 19. What is the proportion? It's 0.633. This is very far from expectation, right? But by the time you continue to watch over several weeks, what happened? This is like, it's getting to a point of convergence here. Does that make sense? That's why it's 0.517. Very close to that, so which means on the long run, that's exactly what you're going to have. You know what? I don't want to rush you. I'm going to stop here today. Then I'm going to continue from where I stopped. Is there any question at this time? Okay. Make sure you stay safe and have a lovely day. You're welcome.